Welcome to the Ham Radio Nomad Extra Amateur Extra Study Session. In this, we go through the study questions on hamstudy.org, and if anyone wants to join us, you're welcome to click the StreamYard link that I have pinned to the top, and I will bring you in, and you can go around and read the questions together. So let's get started. First question: what is one advantage of JT65 mode? A. Easily copied by ear if necessary. B. The ability to decode signals which have a very low signal-to-noise ratio. C. Permits fast-scan TV transmissions over narrow bandwidth. D. Only uses 65 Hz bandwidth. I'm going to go with B. Ability to decode signals which have a very low signal-to-noise ratio. And that is correct. How are capacitors and inductors of a low-pass filter pi network arranged between the network's input and output? An inductor is connected between the between the input and ground. Another inductor is connected between the output and ground, and the capacitor is connected between the input and output. B. Two inductors are in series between input and output, and a capacitor is connected between the two inductors and ground. C. The capacitor is connected between the input and the ground, and another capacitor is connected between the output and the ground. An inductor is connected between input and output. D. Two capacitors are in series between the input and output, and an inductor is connected between the two capacitors and ground. This one is difficult. I'm just going to go with D. Nope, it is C. The capacitor is connected between input and ground. Another capacitor is between output and ground. And the inductor is connected between the input and the output. What happens to linear polarized radio waves that split into ordinary and extraordinary waves in the ionosphere? A. They become depolarized. B. They become elliptically polarized. C. They become phase-locked. D. They are bent towards the magnetic poles. I'm going to guess B. They become elliptically polarized, and that is correct. What is the magnitude of the current at the input of a parallel RLC circuit at resonance? A R over L. B minimal. C maximum. D R over L. And going to go with maximum. Nope, it is minimum. What is the purpose of C2 in the circuit shown in figure E7-2? C2 is a capacitor connected to ground. So A, to provide fixed DC basis for Q1. B, it is a brute force filter for the output. C, to self-resonant at the hum frequency. D, a bypass rectifier output ripple around D1. I don't know. By the choices of guessing and come across, it is D, a bypass rectifier output ripple around D1. If you see closely, C2 is connected in parallel to D1. This will basically act as a filter across D1 and prevent oscillations across D1 and hence prevent uh, prevent the hum. Remember the term bypass capacitor, and that and that a bypass capacitor will pass above certain wavelengths of AC current while blocking DC current. Bypass capacitors are very common for eliminating undesirable AC current such as noise. What is the primary advantage of using toroid core instead of a solenoidal core in an inductor? A. Toroidal cores have lower Q characteristics. B. Toroidal cores confine most of the magnetic field within the core material. C. Toroidal cores make it easier to couple the magnetic energy into other components. Toroidal cores exhibit greater hysteresis. I'm probably slaughtering the pronunciation of that. I'm going to just guess A. Nope. It is B. Toroidal cores confine most of the magnetic field within the core material. Under which circumstance might the FCC issue a special temporary authorization to an amateur station? A. To provide for experimental amateur communication. B, to provide additional spectrum for personal use. C, to provide temporary operation while awaiting normal licensing. D, to allow regular operation on land mobile channels. B, I don't think they really care about personal use. C, I don't think they really care about speeding things up for just normal licensing. D, allow regular operation. That sort of goes against special authority. So I'm going to go with A, to provide for experimental amateur communication. And that is correct. Hey Lee, welcome to the channel. If you are going to say answers, can you include part of the answer or part of the question so I know which question you are guessing at? Which point on figure E5-1 best represents the impedance of a series circuit consisting of a 300 ohm resistor and a 19 picofarad capacitor at 21.2 megahertz? A, which is, let me zoom in so I can actually read these points. A, point 1, which is 300 and 300x and negative 400y. Point 3, 300x and 400y. Point C, point 8, which is 300x and 52y. And point D, negative 300x and negative 400y. I'm going to go with point 1, A, and that is correct. Good evening, Lee. How is your day going? Have you been able to get on the airwaves at all today? And this is the impedance of the capacitor is denoted as the inverse of 2 pi, the frequency, times the farads. So in this case, it is 300, which is the resistance, minus 395 ohms. Or, sorry, farads. Excellent work on getting 9 last man standing stations. I've kept my eye out for them when I was on FT8, but I haven't. The bands for me have been pretty lousy, so I have not been able to see any of them so far. I might take a look at. I might be watching Jason's channel, Jason Ham Radio 2.0's broadcast this evening and seeing if I can seeing if I can hear anything tonight. How does the maximum range of ground wave propagation change when the signal frequency is increased? A, it stays the same. B, it peaks at roughly 14 megahertz. C, it increases. D, it decreases. So this is referring to ground wave propagation, and I don't believe that the signal frequency changes ground wave. It changes how it is reflected over the atmosphere in the atmosphere, but I don't believe ground wave is changed. But let me see. So I'm picking A, and I am wrong. So it is D. The maximum range decreases as the signal frequency is increased. Ground waves are waves than emitted at less than a wavelength above the ground that travel in contact with the surface of the Earth. At higher frequencies like most HF and above this is especially bad. The waves are severely attenuated and nothing amazingly good happens. At 160 meters and below, frequencies with at 160 meters and below, frequency with vertical polarization, though they might be able to travel a few hundred miles since they can get refracted in such a way as to follow the curve of the Earth without much attenuation. Whereas at 10 meters, they tend to die in about 10 miles or less. Note that this requires vertical polarization. Horizontal waves will short circuit immediately since the whole electric field tends to end up in the somewhat conductive ground. How well surface wave propagation works depends on the conductivity of the soil or water that makes up the Earth's surface on the path. Ground wave propagation is most useful on the 1.8 megahertz and the 3.5 megahertz bands during the daytime. What is the function of vertical inter, interval signaling (VIS) code, which is part of an SSTV transmission? A, to identify the SSTV mode being used. B, to lock the color burst oscillator in color SFTV images. C, to identify the call sign of the station transmitting. D, to provide vertical synchronization. I'm going to guess D. Nope. It was A, SSTV, to identify the SSTV mode being used. Trick to remember, VS code identifies the mode. What is the primary cause of inductor self-resonance? A, nonlinear core hysteresis. B, interturn capacitance. C, inductive kickback. D, the skin effect? I do not know, so I'm just going to guess until I get the right answer. And the right answer turns out to be B, interturn capacitance. Self-resonance happens when you have both inductive and capacitance in series. How are impedance described in polar coordinates? A, by phase angle and magnitude. B, by Y and G values. C, by real and imaginary parts. D, by X and R values. um, I believe it's C. Nope, I'm wrong. It is A, phase angle and magnitude. Impedance are described by vectors having an angle, phase angle, and magnitude or amplitude. This is similar to another question in the pool about vectors. Uh, what is meant by the term baseband in radio communications? A, the lowest frequency band on the transmitter or receive that the transmitter or receiver covers. B, the frequency range occupied by a message signal prior to modulation. C, the unmodulated bandwidth of the transmitted signal. D, the basic oscillator frequency in a FM transmitter that is multiplied to increase the deviation and carrier frequency. I'm going to go with C, the unmodulated bandwidth of a transmitted signal. And nope, is B, the frequency range occupied by the message signal prior to modulation. How does the maximum range, and did this one already? Bunch of ones we did already tonight. What is the effective isotropic radiated power of a repeater with 200 watts transmitted power output, 2 dB feed line loss, 2 dB duplexer loss, 1.2 dB circulator loss, and 7 dBi antenna gain. So we have total of losses is 3, 4, 5, 6, and we have 7 dBi gain antenna. So I'm going to say just a high bit over, a little bit more than the 200 watts. So I'm going to guess D 252, and that is correct. Which of the following digital modes is especially useful in EME communication? A. Pactor 3, B. Olivia, C. MSK 144, D. JT 65. I'm going to guess JT 65. Yep. JT 65 was designed as a digital protocol for extremely weak signals. As such, it is of particular use in EME, Earth Moon Earth communications on the VHF bands. What is the What of the following types of modulation is common for digital emissions below 30 megahertz? A. Pulse modulation, B. FSK, C. DTMF tone modulation on a FM signal, D. Spread spectrum. I believe most of the modulation is a FSK modulation. It isn't C because that's on an FM signal, and FM signal is VHF and UHF, which is above 30 megahertz. But yes, it is FSK. And below 30 megahertz, DTMF with FM signal would take a large amount of bandwidth as well as spread spectrum. The only other options are pulse modulation and FSK. Commonly, frequency shift keying (FSK) is used on these bands, which modulates the frequency a bit with data. So we get our interesting, what is the antenna radiation pattern? What is the radiation pattern of two 1/4 wavelength vertical antennas spaced half a wavelength apart, fed 100 degrees out of phase? A figure 8 broadside to the axis of the array, B choroidal, C omnidirectional, D figure 8 oriented along the axis of the array. I think the other one was the figure 8 is quarter length, and so I'm going to guess D choroidal, they think is the one that's half a wavelength apart. And I am wrong. It is figure 8 oriented along the axis of the array. And we have so this is this website here that I'll post into the chat talks about how the wavelength pattern looks depending on whether the signals are in phase and how far apart they are. So you have one for two antennas quarter wavelength apart in phase, two antennas half wavelength apart in phase. So we have, this is what they look like if they are in phase. A figure eight up and down, and if they're out of phase, it's a figure eight left and right. So it is a figure eight oriented along the axis of the ray. So if you have the two antennas along the x-axis, then the figure eight will also be along the x-axis. Which of the following conductors would be best for minimum loss in station RF grounding system? A. Solid wire. B. Stranded wire. C. Resistive wire, such as a spark plug wire. D. Wide flat copper strap. In grounding, they typically use a copper strap. So I am going to pick D. That is correct. Wide flat copper strap. Which of the following is a significant difference between foam dielectric coaxial cable and solid dielectric coaxial cable, assuming all other parameters are the same? A. Foam dielectric has higher velocity factor. B. All these choices are correct. C. Foam dielectric has lower safe operating voltage limits. D. Foam dielectric has lower loss per unit of length. I'm going to guess D. Nope. It is B. All of these answers are correct. Which HF amateur bands have frequencies authorized for space stations? A. Only 40, 20, 17, 15, and 10. B. Only 40, 20, 17, 15, 12, and 10. C. Only 40, 30, 20, 15, 12, and 10. D. All HF bands. I'm going to guess B, and that is correct. Which is one type of electrical interference that might be caused by a nearby personal computer? A. A whining type noise that continually pulses on and off. B. the appearance of unstable modulated or unmodulated signals at specific frequencies. C, a clicking noise at intervals of a few seconds. D, a loud AC hum in the audio output of your station's receiver. I'm going to guess B, appearance of unstable modulated or unmodulated signals at specific frequency. And that is correct. A CW receiver with the AGC off has an equivalent input noise density of negative 174 dBm over Hertz. What would the level of an unmodulated carrier input to this receiver that would yield an audio output of SNR of 0 dB in 400 Hertz noise bandwidth? I'm going to pick B, just because um, I don't know the right answer. So the right answer is negative 148 dBm. Signal to noise ratio of 0 dB means 1 to 1 because log 1 over 1 equals 0. So 400 hertz of bandwidth translates to the output level. So 10 logarithmic 400 equals 26 dBm. So negative 174 dBm plus 26 equals negative 148 dBm. Which of the following is an aspect of piezoelectric effect? A, generation of electrical energy in the presence of light. B, mechanical deformation of material by the application of voltage. C, mechanical deformation of material by the application of magnetic field. D, increased conductivity in the presence of light. I'm going to guess D, increased conductivity in the presence of light. And that is wrong. It is B, mechanical deformation of a material by the application of a voltage. What is one reason for using ferrite cores rather than powdered iron as an inductor? A, ferrite toroids are easier to use with surface mount technology. B. Ferrite toroids generally require fewer turns to produce a given inductance value. C. Ferrite toroids generally have lower initial permeability. D. Ferrite toroids generally have better temperature stability. I'm going to guess B. Ferrite toroids generally require fewer turns to produce a given inductance value. And that is correct. How many flip-flops are required to divide a signal frequency by 4? A. 2, B. 4, C. 1, D. 8. I'm going to guess A. 2. That is correct. So my guess is each flip-flop divides it by 2. So if you divide and that compounds it, so you divide the answer by 2, divide the signal by 2, and then you divide it by 2, you will get that comes up to 1/4. What is indicated if the current reading on an RF ammeter placed in series with the antenna feed line of a transmitter increases as the transmitter is tuned to resonance? A. There is more power going to the antenna. B. There is an impedance mismatch between the antenna and the feed line. C. The transmitter is not properly neutralized. D. There is possibly a short to ground in the feed line. I'm going to guess A. There's more power. If the ammeter increases, then that means there's more power going to the antenna. A CW receiver with the AGC off has an equivalent endpoint. We did that one already. So it is. I don't believe this is the same question we had before, but it is the same numbers. So it is a negative 174 dBm with a 400 noise bandwidth. What is one of the potential hazards of operating in amateur radio microwave bands? A. Microwaves are ionizing radiation. B. Microwaves often travel long distances by isospheric reflection. C. The high gain antennas commonly used can result in high exposure levels. D. Extremely high frequency energy can damage joints of the antenna structures. I'm going to go with C. The high gain antennas commonly used can result in high exposure levels, and that is correct. Which of the following is a significant difference between foam and solid? And that is, all of these are correct. Since we've already seen this one correctly, we've seen this one today. How much gain does an antenna have compared to a half-wave length dipole when it has 6 dB gain over an isotropic antenna? And I believe that everything is compared to a half wavelength dipole, so that would be B, I believe. Nope, I am wrong. The answer is A, 6.85 dB. Okay, so looks like one thing you're just going to need to remember is half wavelength dipole is approximately 2.15 dB gain over an isotropic antenna. Under which circumstances may a dealer sell an external RF power amplifier capable of operation below 144 MHz if it has not been granted FCC certification? A. It was imported from a manufacturer in a country that does not require certification of RF amplifiers. B. It was imported from a manufacturer in another country and was certified by that country's government. C. It was purchased in used condition from an amateur operator and is sold to another amateur operator for use at that operator's station. D. The equipment dealer assembled it from a kit. I'm going to guess C, and that is C is correct. It was purchased in used condition from an amateur operator and is sold to another amateur operator for use at that operator's station. Older equipment that was produced prior to new regulations and can be used in a legal manner are allowed to be sold by hams. Name what is the name of the matching system that uses a section of transmission line connected in parallel with the feed line at or near the feed point? I think I've seen this question like several times and I keep getting it wrong. I'm going to go with B, stub match. That is correct. And memorization trick: a section of transmission line equals is referred as a stub. What happens to the magnitude of a pure reactance when it is converted into susceptance? It is shifted by 90 degrees. B, it becomes reciprocal. C, it is unchanged. D, the sign is reversed. I'm going to guess D, the sign is reversed. Nope, it is B, it becomes reciprocal. When AC passes through a component that contains a finite zero non-zero susceptance, energy is alternatively stored in and released from a magnetic or electrical field. In the case of a magnetic field, the subsubstance is inductive. In the case of an electric field, the subsubstance is capacitive. Inductive capacitance is assigned negative imaginary numbers. Capacitive susceptance is assigned positive imaginary values. How can the output voltage of a multi-turn receiving loop be increased? A. By winding adjacent turns in opposing directions. B. By increasing the number of turns and/or the area. C. By reducing the permeability of the loop shield. D. By utilizing high impedance wire for the coupling loop. I don't know. I'm gonna guess the utilizing high impedance wire for the coupling loop. Nope. The correct answer is B, increasing the number of turns or the area. More voltage, more length, either through loops or actual length of the antenna. What is meant by circularly polarized electromagnetic waves? Waves with a rotating electrical field. B. Waves that circle the Earth. C. Waves produced by a loop antenna. D. Waves with an electric field bent into a circular shape. I'm going to guess B, or sorry, D, and I'm wrong. It is A. Waves with a rotating electric field. What type of antenna pattern is shown in figure E9-2? A. Polarization. B. Radiation resistance. C. Elevation. D. Azimuth. And this is over real ground, and the degrees are the degrees of elevation, so I'm going with C, elevation. What is the bandwidth of a 4,800 hertz frequency shift 9600 baud ASCII FM transmission? A, 5.67 kilohertz, B, 9.6 kilohertz, C, 4.8 kilohertz, D, 15.36 kilohertz. I'm gonna pick B, 99.6 kilohertz, even though I think that's wrong. I don't like any of the other, don't like any of the other answers, but the correct answer is D, 15.36 kilohertz. And there is a nice equation. Bandwidth equals K, which is 1.2 time shift plus the baud rate. So short answer is short hint would be you add them together and look for the answer that's bigger than that. And the only one that would be bigger than that was the 15K. Which of the following can be measured with a vector network analyzer? A, reflection coefficient. B, all these answers are correct. C, input impedance. D, output impedance. I'm going to guess all these answers are correct, and that is the correct answer. What will be the output voltage of a circuit shown in figure E-7 if R1 is 1,000 ohms, RF is 10,000 ohms, and 0.23 volts DC is applied to the input? Oh, I'm going to guess D. So it's A, negative 2.3 volts, B, 2.3 volts, C, negative 0.23 volts. 73, Lee. Yep, this will be my last. This will be my last question. Thanks for watching. D, 2.3, and I am going to go with B, 2.3. Nope. So it does. It is A, negative 2.3. Gain equals negative RF over Rn. So negative 10 kiloohms over 1 kiloohm equals negative 10 is your gain. Thank you for everyone and watch. Head over to Jason's stream, and we will see you next week for another study session. And also, please join us on Thursday night for Thursday night ham radio. I will be doing a practice session beforehand, and then we have the FT8 off at wrapping up the night. Also, join us for Monday night ham radio, which is tomorrow night. So, 73 to everyone, and hope to see you again on a stream later this week. Take care.